Hello everyone, welcome to an algebra video tutorial. We are applying exponential functions. In this particular video, we're going to be working with the compound interest formula and dealing with exponents, exponential functions, and money and interest. It's all very, very interesting to us as we want to make our money work for us, right? We want to be able to save money, get interest on the money we're saving, all that kind of good stuff. So here we go. Here's our problem, and then we'll break it down. If you want to invest $5,000 for 8 years at 4.5% interest, how much would you have at the end if your interest was compounded monthly? And how much would it have if it compounded daily? So compound interest is this idea that if you're investing, here's our growth rate, right? Our money's going to grow by this much per year. But compounding monthly means every month I grow by a part of that. Compounding daily means every day I grow by a part of that 4.5% interest. So let's take a look at the compound interest formula and try and make more sense of it. Here's what we're talking about with compound interest. The amount of money that you'll have, A, is equal to the principal P, that's the money you're starting with, just like in our exponential formula. We're going to multiply by 1. That's the amount I multiply to stay the same, but I'm growing by my interest rate divided by n. And n is just how many times am I compounding in the year. And then we take that to the power of n times t. So it looks really, really complicated, right? But it's essentially our exponential function formula. A starting amount, what we're multiplying by, and how many times we want to multiply it by. So it's just the same pattern of repeated multiplication. So let me write some things out here. A is the amount you have, amount total. P is your principal, starting amount. Well, let me write principal here. Principal. R is your yearly interest rate. We have to turn that into a decimal. So even though it's 4.5% interest, I'm not going to put 4.5. I need to turn that into a decimal. And then N is the number of compounds per year. And finally, we got T. How many years are we doing this? Number of years. All right, hopefully that makes sense of what this formula is about, at least what all the different letters mean. It just has a lot of meaning. In our problem, we know that we're investing $5,000. So guess what my principal is? It's $5,000. I'm going to put that in. That's my starting amount. We're going for 8 years. So that's my value for T is 8. At 4.5% interest, so for R, I'm going to put, I got to turn that into a decimal, so I take 4.5 divided by 100, and I get 0.045. That's my yearly interest rate. I'm growing by that much over the year. But now I have to think about the number of compounds. So compounding monthly would mean I'm going to do 12 times per year. So I'm going to put 12 in for n. But if I compound daily, well, that's 365 times a year, right? So I'm going to put that in for n. So there's a couple different things, a couple different ways we're going to go about doing this. We're going to calculate how much we would have if we compounded monthly, and then we're also going to calculate if we compounded daily, just so you can see just kind of the awesomeness that compound interest is. All right, let me draw a little line here, and then let's do both of these examples. So we're going to do monthly on the left, stroke a line, and we're going to do daily on the right. All right, so monthly, let me switch to a nice color here. So here's monthly. All right, let's put everything in and do some calculations. So if I put everything in that I know into my formula, the amount I'm going to have is equal to $5,000. I'm investing it at 1, but I'm growing from that, so it's plus 1 plus. My interest rate for the year, 0.045, divided by 12. So I'm basically taking that 4.5% and I'm dividing it by 12 because there's 12 months. So I'm going to do a part of it each month. But for 8 years, 12 months times 8 years is going to be 96 total times once I multiply my exponents. So that's where the n times t happens in. If I'm only doing a part of my percentage over a month, then I have to multiply it more often. Okay, so let's calculate what all this equals now. So 0.045 divided by 12. So I can rewrite that then now as 5,000 times 1 plus 0.00375 to the 96th power. So I'm just simplifying some things here. And if I go put all that in, 5,000 times 1.00375 to the 96th power, we get that my amount equals $7,161.82. All right, so that would be with compound interest. I started with $5,000 and I ended up with $7,161, and I didn't have to add any extra money. So over 8 years, I made almost over $2,000. That's pretty nice return. Let's take a look now. Let's do daily. Let's switch colors here. So on the right side, we're going to do daily now. So what if I compound things daily? So it's still finding A, the same principal, $5,000. But now I'm going to do 1 plus, it's still my yearly interest rate, 0.045. But now instead of breaking it into 12 months, I'm going to break it into 365 days. So I'm going to divide it by that 365. Well, if I'm dividing into 365 periods, now I got to do 365 days times 8 for how many days are in 8 years. So it's a little bit more complicated. It's going to be a little more messy. Thank goodness we got some good calculators. But this is going to help us get our daily rate. Okay, let's go ahead and start calculating this thing out here. I'm going to do 0.045 divided by 365 and see what decimal I get. And I get, if I simplify all that and then add the 1, I get 1.0000123. Then we'll go to 9. So I have to be a little bit more precise because I'm taking the exponent so many times that any rounding I get, so I'm going to do 365 times 8, that's going to be 2,920. So that's 2,920 times I'm multiplying by this number. So if I even round just a tiny bit or get just a tiny bit imprecise, it compounds and it compounds, and it can actually throw it pretty far off if I'm not careful. So I'm trying to be a little bit more precise to make sure I get a better answer here. So we still got a principal of $5,000. There's my amount, and let's see what all of this comes out to equal now. So 5,000 times 1.000122329 to the 2,920 power. And we get that my amount is equal to $7,166.54. All right, so let's compare them now. It looks like I made almost $5 more which isn't that much, right? But you know, it's a hamburger. We got $5 more if we do daily compounds versus if we do monthly compounds. So the point is, the more you compound, the slightly better it gets in your favor in terms of interest. It's the opposite is in terms of debt. If you have debt and you're paying interest on your credit card debt, then daily compounds are working against you as opposed to monthly compounds. But there you go. That's compound interest. That's the compound formula, and it's a direct application of using exponents and exponential functions. And just thinking about our starting value being the principal, the amount of money we're investing, and we're multiplying by whatever our interest growth is. And we just need to determine, well, are we multiplying it every month? Are we multiplying it every day? Or multiplying it weekly or yearly? And considering then how many times we need to multiply that out. So hopefully that's helpful for you if you are working on compound interest and trying to figure out all this compound interest stuff.